2.8 Naming inorganic compounds. Now, in AP Chemistry, you'll really only have to deal with inorganic compounds. There might be some organic compounds like ethane, methane, um, butane, propane, but in reality, you only have to deal with these. I mean, methane comes up pretty often, but um, just focus on this right now because you'll probably have to go over some nomenclature rules or naming rules later on in AP Chemistry. So first, let's go over some common names. These include water and ammonia. Everyone knows that water is H2O, and not many people know that ammonia is NH3. Um, so if we go over the naming rules, water would technically be called dihydrogen monoxide, but nobody calls it that, and that's really not the proper name. So it's important to note that there are a few exceptions to these naming compounds. I'm not sure why they're exceptions, probably just because they're so widely used. Um, so water and ammonia are simply just the names for H2O and NH3. So first we have organic compounds, which are just carbon and hydrogen. Um, Deals with a lot of hydrocarbons, and all hydrocarbons are just molecules with only carbon and hydrogen. Schnapps, which I like to call it, are the primarily organic elements. So that's what you'll see in organic chemistry: carbon, hydrogen, nitrogen, oxygen, phosphorus, and sulfur. But you won't have to know any naming rules for them. I mean, this is really in the future. If you're curious about it, you can search up the IUPAC naming convention. But you're definitely not gonna. That's way too complex. I mean, like even me, I don't really know how to name them. I know you start at like I believe it's the carbonyl groups, and you see if there's ketones or aldehydes. Um, but no, it's just way too complex. Inorganic compounds are everything else, and this is what you're going to be dealing with in AP chemistry. So first, they're divided into ionic compounds, molecular compounds, and acids. These are all the naming rules you'll need to know. So ionic compounds are cations, which, as we know, are positive ions, meaning that the atom lost an electron. Their name stays the same as the element. So if we have like lithium plus, that would just be lithium. If we have sodium plus, that would be sodium. Um, so anything basically in the alkali metal, and alkali earth metal, are going to just be called its name, and also some of the transition metals. But the transition metals are typically variable charge, meaning that they can either exist as +2 or +3 ions, or there's just numerous ions that can exist within those transition metals. So I have an example right here. And you only add the Roman numerals after if there are multiple charge ions. So iron has Fe+2, but it also has Fe+3, I believe. Wait, no. Um, I believe iron has two oxidation states, and oxidation states just mean the ionic charges. So there's Fe+2 and another Fe. I forgot if it was +3 or +4. But I'm pretty sure it's +4 because +3 is just aluminium, bismuth, gallium, and indium. Um, but you use Roman numerals, so Fe+2, which means iron with a charge of 2, is going to be iron 2. But you can add the name at the end like iron 2 ferrous. And ferrous is just an old name. Is always comes with the one that is the lower charge. And ic, so ferric, is going to be the higher charge. So I believe that would be iron 4 ferric. Or whatever oxidation state is next for iron. I'm not too sure. So simply put, for metals that have variable charges, meaning there can be numerous ions that exist for that metal, it's going to have Roman numerals at the end. And then you'll have, I believe this is a Latin name. For non-metal cations like ammonium and hydronium, you only use the names, and there's other ones too, but these are primarily the ones you'll use. So, for monatomic anions, there's one element, and they end in "ide." So these are typically dealing with the nonmetals at the right side of the periodic table. So we have chloride, fluoride, and that's really simple. So yeah, for oxyanions, which are just anions with oxygen, they end in "ate" or "ide." So 8 is the highest one, which is not necessarily true. I mean, yeah, it is true. But there's things like perchlorate. And so for perchlorate, there's actually two ions that end with 8 here. There's chlorate, which is ClO3, and then there's perchlorate, which is ClO4 minus. So per just means one more oxygen. So we have an example right here. ClO2 minus is chlorite. ClO minus is hypochlorite. So hypo is one less, per is one more. So adding hydrogen to name, simply add dihydrogen or dihydrogen. Simply add hydrogen or dihydrogen. Other acids have different naming conventions, but ions follow this. For example, examples include hydrogen carbonate, which I forgot to put the H before that, but there should be an H right there, or dihydrogen phosphate. There's dihydrogen arsenate, and stuff like that as well. But if they're ionic acids, then you name it like this. But other acids have different naming rules, which we'll get to later in this video. Ionic compounds, you just say the names together. So as we've mentioned before, these are ions, so technically they don't change. They just come together. So this one is called ammonium, as we've mentioned before, and this is called chloride because monatomic anions always end in "ide." So this is just going to be ammonium and chloride, and combined together is ammonium and chloride. Another example is everyone's favorite table salt, sodium chloride, which is Na+. And since that's a monatomic cation, it's going to be sodium, which because the first doesn't change because it's a positive cation, and the chlorine because it's a negative monatomic anion, it's going to be chloride, so sodium chloride. For naming acids, if anions end in "ide", simply add hydro plus root plus ic. So as we mentioned before, Cl is chloride, or Cl minus is chloride, and H plus is just hydrogen. So because an acid is whatever has a hydrogen, typically in the beginning, it's going to be hydrochloric acid, because you add hydro plus the root plus ic. So if it's a nonmetal or a monatomic anion, you just add hydro, root, and ic. And if the anion ends in "ate" or "ite", such as perchlorate over here, you just change the last part to "ic". If it ends with "ite", it's going to change to "us", so hypochlorous acid. So covalent compounds are made of two nonmetals, as we've all known. Naming rules: simply use a Greek prefix for each one. 1 is mono, 2 is di, 3 is tri, 4 is tetra, 5 is penta, 6 is hexa, 7 is hepta, 8 is octo, 9 is nona, and 10 is deca, I believe. So if the first there's only one exception to this, and it's if the first element only has a subscript of 1. So typically you're supposed to use these to represent the amount of subscripts there are. But if the first element only has a subscript of 1, there's no need to put that. I'm not sure why, but that's just how it works. And lastly, the second element must end in "ide". So for example, here we have carbon monoxide. But since this beginning one has a subscript of 1, we don't put monocarbon monoxide. I'm not sure why, but since O has a subscript of 1, because it's 1 carbon, 1 oxygen, it's going to be carbon monoxide. So even though there's 1 in front of the carbon, we don't say monocarbon monoxide. If there was 2 carbons here, we would say dicarbon monoxide, which I'm not sure if that actually naturally forms or if that's a real molecule, but that's just an example I used. So that's it.